Hey there guys, welcome to the notes for 8.3 quadratic transformations. So in the previous notes you've seen this similar shape, the parabola, the U shape for quadratic functions. Now we're going to get a little bit more specific. This quadratic function that starts at the origin, that starts at 0, 0, is something we call the parent function. And like the name suggests, this is the function by which all other functions come from. So when we're talking about transformations, we're talking about transformations in regards or in relation to the parent function. So when we're saying we're moving up or down or left or right or we're reflecting, we're really saying from the origin. So from the origin, I'm going up or down. Or from the origin, I'm going left or right. So the parent function starts at the origin. So when we look at the transformations here, you'll see kind of what we mean. Now for horizontal transformations, we know that horizontal means you're going left and right. Now, we've seen this similar when you've done linear transformations. If you remember, horizontal transformations, you can look here, are transformations that happen inside the parentheses. And when you're inside the parentheses, remember, you're the opposite. So you'll do the opposite of what you usually think of. Now, by inside the parentheses, what we mean is our parent function starts just as f of x. However, now inside the parentheses, instead of f of x, you have f of x plus a number. So that's a change. That's a transformation that's happening. You're adding a number to the original x. If this happens, well, when you're adding, a lot of times you think, oh, we're going right, because you're adding. But remember, it's opposite. So instead, when you're adding, you're going to go to the left. But you don't just want to say you're going left, you want to be specific. Left, however number you're adding. So if I was adding 5, it would be left 5. Conversely, if you're subtracting within the parentheses, so if you have f of x minus a number, instead of going to the left where you usually would think, you're actually going right. So horizontal transformations are usually where students will make small mistakes because they forget it's opposite. So be very, very careful. When you're adding, you're going left. When you're subtracting, you're going right. Another area where students make small mistakes are here, the difference between subtracting a number and having a negative number. So the subtraction sign and the negative signs are the same, more or less. The only difference is the placement. Subtraction signs are between two items, so in this case it's between x and a number. Negative signs are in front, so it's just in front of x with nothing really to the left of it. So this isn't minus x, this is negative x. When you have a negative inside the parentheses, you are reflecting across the y-axis. Which makes sense. If you're putting negative to your x, what used to be a positive 5 is now a negative 5. What used to be a negative 3 is now a positive 3. Notice you're jumping between the y-axis. So as you're flipping signs from negative and positive, you're reflecting across the y-axis. Now here are also some tricky ones, compressions and stretches. If you can kind of imagine a rubber band, if horizontally I'm making this number smaller, well, it's kind of stretching. It's easier to see for these, but what you can think of, usually fractions make you think, oh, it's getting smaller. But remember, we're opposite. So instead of being a horizontal compression, we have a horizontal stretch. And similarly, usually you think whole numbers make things bigger, but since it's opposite, this is a horizontal compression. So these are all your possible horizontal transformations. And notice they're all happening inside these two parentheses. Whereas when we go into vertical transformations, well, we know vertical means we go up and down. So vertical transformations are going up and down. Notice these went left and right. For my vertical transformations, these happen outside of the parentheses. And outside the parentheses, we are the same. So you're not going to do the opposite. You can do exactly as it tells you. Case in point, if I look to my first one, I have f of x. Notice there's nothing inside the parentheses. I stayed f of x. However, outside the parentheses, I now see I have a plus a number. Well, that means I have a vertical transformation since I'm outside the parentheses. Do as you're told, so it stays the same. So since it's plus, it makes sense that it's up. How many you add. So if it was plus 5, it would be up 5. Likewise, for minus a number, you're going to go down that number. Which makes sense, you have vertical transformations, so you're going up and down. Now this one, sometimes students miss, really, really important. The negative sign on its own is its own transformation. So if you had negative 1/2, that's 2 transformations. The negative counts for its own thing. The negative tells you you're reflecting across, this one's across the y-axis, this one's across the x-axis. Let me see if I can. Which makes sense. This means your y values are switching signs. So here if I had a positive 4, I now have a negative 4. If I had a negative 10, now I have a positive 10. Notice here when you're switching signs, you're reflecting across the x-axis. This one, exactly as it seems, when it's a fraction, it makes sense that it's getting smaller. So this is a vertical compression. And whole numbers would make it bigger. And it's exactly as it seems, the same. So it is a vertical stretch. So these are all my horizontal and my vertical transformations. So we look to my first example. Notice there are no parentheses at all. So we're talking about inside the parentheses, outside the parentheses. But for example 1, there are no parentheses. That means you're only working with vertical transformations. If you do not see parentheses, that's because there's no horizontal transformations, nothing happening inside. So you're only looking at things outside. So you see a few things. You see that I'm adding 5 right here. And you see that you have a 2 in front. So let's call this transformation 1, transformation 2. My first transformation is here, the 2 in front. So this number goes after, this number goes after, so I'm looking for something in front of my f of x. Negative, but this number isn't negative, so it's not a reflection. So it's one of these. Now 2 is a whole number, so I have a vertical stretch. But you want to be specific by 2, because that's how much you're stretching. My second transformation is this plus 5, after the x. Well, I can see that I have 2 options that happen after. I'm either moving up or down. This is plus 5, I'm moving up 5. And that's it, you're done. So all you're doing is describing what's happening. This might seem familiar because you did the same thing with linear functions. Example 2, now you do have parentheses, so now we are inside the parentheses, but you are also outside. So let's start left to right. So the first thing I can see is that I have a plus 4 inside the parentheses. Well, while I'm inside the parentheses, here are my transformations. Now, it's adding or subtracting after the x, so my only options are here, moving left or right. Since I'm adding, it's the opposite, I'm going left. So transformation 1 is going left 4, since you added 4. Transformation 2, however, is outside the parentheses. So it is a vertical transformation. Since it's minus 3, it's the same, so minus means down. So transformation 2 is down 3, since you did minus 3. More or less, the more you get these, the more you start to memorize. It's really important to memorize more or less this table. You're not given this table on the star or on a test, so make sure you know what's a compression, what's left, what's right, what's vertical, what's horizontal. Example 3, we have something outside, that negative, and you have something inside, that minus 2. You also have something outside again, that plus 7. So in this case, you have 3 transformations. My first transformation is here, outside. I color-coded it blue, because it's going to be one of these. It's a negative outside. So first off, notice this is in front of the parentheses. So since it's in front of the parentheses, it cannot be these 2. It has to be one of these 3. It's just a single negative, so so it's a reflection across the x-axis. Transformation 2 is inside the parentheses, so I'm horizontal. It's minus after the x, so minus after the x. I'm going right that number. I'm going right 2. Finally, I have a third transformation right here. It's outside the parentheses, so I color-coded it blue, and you're adding afterwards. Well, adding afterwards tells me I'm going up. So these are my 3 transformations. Reflect across the x-axis because of the negative, right 2 because of the minus 2 inside the parentheses, up 7 because of that plus 7 on the outside. Now for number 4, I would take a second and try to, in your head, tell yourself how many transformations are here. Usually students will get this incorrect. So see if you can get it correct. So after a few seconds, ideally, you should have said there are 1, 2, 3. Sorry, I'm trying to color code. 4 transformations. So if you say there's 3 transformations, that's probably because you put numbers 1 and 2 together. Transformation 1 and transformation 2 are 2 separate transformations. The minus sign would be on its own. So, minus in front. Now, notice it's outside the parentheses, so it's not horizontal, that's why I made it blue. Outside the parentheses, minus sign, or, to be particular, negative, means I'm reflecting this time across the x-axis. So, reflecting across x-axis. Transformation 2, it's on its own, so do not put 1 and 2 together. Do not say negative 1/2 is just a vertical compression. It is a vertical compression, just because of the 1/2, but the negative is its own transformation. It's a reflection. So I see 1/2, that one matches this 1/2, luckily. So it is a vertical compression by 1/2. Transformation 3 is inside the parentheses, which is why I color-coded it green. Plus 3 means I'm going to be opposite. So I'm going to go left 3. Oops. Final transformation is not inside, it's outside, but it's after. Well, the ones that are after are here. It's minus, so I'm going to go down 6. So that's how you write transformations from an equation. But sometimes you're given the descriptions and you have to write the equation. So to do that, what I always like to do is write h of x. You can use any letter really. You can say j of x, k of x, m of x, n of n, x. I like to use h, but you can use any letter. H of x equals, where h is my transformation. Notice these are all different letters. Let's read the problem. Now I like to leave a space, an f, a space, because there might be a negative or a fraction in front of x, a space, because I might be adding or subtracting. There we go. So I always like to set this up, in case there's something in front of the parentheses, in front of the x, inside the x, or after. So let's see, we have a quadratic equation for, this is my parent function, remember, this is the original thing, when it's translated 1 unit to the left or right, it's horizontal. That means I'm inside the parentheses. And 5 units up and down is vertical. Now 5 units up, I know it means after the parentheses, I'm just going to write plus 5. 1 unit to the left, well that means I'm inside the parentheses, but be careful, left is plus. So it's not minus 1, it's plus 1. And that's my equation. H of x equals f of x plus 1 plus 5. You could have also written it as keeping the squares. Same idea, except this time instead of an f, you'll just put parentheses squared, similar to this one. Same idea, except in particular for my quadratic function, I could have written it like this. So these are the same. For example 6, same idea. Let's say I want to use j this time. J of x equals, leave space in front, right in front of x, leave space inside. Write an equation for f of x equals x squared when it's vertically stretched. Well, it's telling me it's a vertical by 2 and shifted right 6. Now, right 6, left or right means horizontal, which means I'm inside. But be careful, right means you're minus. So minus 6. And a vertical stretch means it's a whole number. And it goes in front. So a whole number 2 in front. You could have also written it as same thing, except instead of f of x, just use a squared. So 2x. Notice these are exactly the same. The difference is this is function notation where you have f of x this side, or quadratic notation where it has the x squared. So notice we can interchange between them. These two are function notation, these two are quadratic notation. Either way works. Here's something for you to try on your own. But let's get into domain and range. Puedes entrar.